Your last video walked you through how to go from a formula to a name of a compound. This time we're going to talk about how to go from a name to a formula. And so we're going to use the I-bar again. You'll see up here still that we're using the input, what we're given in the problem. The cation's work area is over on the left. The anion's work area is over on the right. And the output, our final answer, is down here on the bottom. Just like when we were talking about going from formulas to names, the I-bar only works for ionic compounds, which means that it has to be something with a positive charge and something with a negative charge where the opposite charges attract, and that's what holds these ions together. We're going to start down here with our lithium chloride. So if you look, lithium chlorate, we're going to draw an I-bar. Do my I-bar right up here. I was given lithium chlorate, so that goes up here in my input. And now I have to use my periodic table to figure out what my cation and my anion are. So I'm going to find lithium on my periodic table. Lithium is element number 3. Its symbol is Li. And if I look, it's in group 1, so it has an oxidation number of +1. It loses 1 electron. Chlorate, because it ends in ATE, I know that it's a polyatomic ion. So I'm going to look on the back of my periodic table, and I'm going to see that chlorate is Cl O3 with a -1 charge. This is 1 chlorine and 3 oxygens together in 1 anion. On this side of my I-bar, I have a +1 charge. On this side of my I-bar, I have a -1 charge. And remember that we need these two to cancel out or to equal 0. +1 and -1 do cancel out. So I see that I have 1 lithium when I write my formula. And I have 1 chlorate. So I have to keep that whole thing together, ClO3. So my formula for lithium chlorate is just LiClO3. Okay. I want you to go ahead and try calcium sulfide. So pause the video for a minute, draw your I-bar, and write the formula for calcium sulfide. So if I draw my I-bar for calcium sulfide, I hope you did this on your own first. Don't just watch me, because otherwise you'll never figure it out. What I'm given is calcium sulfide. That goes up here. And again, I'm going to look at my periodic table. Calcium is element number 20. It's in group 2. Its symbol is Ca. And if I look at that top of the group, I know that its oxidation number is a +2. Sulfide, because it ends in IDE, is also going to be on the front of my periodic table. So I have to figure out what this element is. Its ending for the element will not be IDE. We talked about that in the last video. We changed the ending here. So this is actually sulfur that has become an ion. The symbol for sulfur is S. And if you look on your periodic table, it has a -2 charge. Well, if I have a -2 charge on this side and a +2 charge on this side, those two cancel out. So again, my formula for this one is pretty easy. I just have a 1-to-1 ratio. I have 1 calcium for every 1 sulfide. We can get a little trickier here, though. I have copper 1 nitride. This Roman numeral tells me that copper is a transition metal. It also tells me that the charge on this copper is a +1. So I'm going to draw my I-bar up here. My input, my thing that's given to me in the problem, is copper 1 nitride. I know from, I know from my periodic table that copper's symbol is Cu. And I know from this Roman numeral here, from this 1, that the charge on copper is a +1. Now over here, my ending is IDE, so that tells me that this is probably on the front of my periodic table also. So here, nitrogen has become nitride. Nitrogen's symbol is N. But if I look at the top of the periodic table, nitrogen's charge is a -3. Well, a -3 on this side and a +1 on this side, those don't cancel out. So I have to figure out what to do so that my cations and my anions will cancel out. Nitrogen needs to gain 3 electrons. It can only gain 1 electron from this copper. I only have copper and nitrogen in my formula, so I'm going to add another copper here. This copper still has a +1 charge because I have a +1 Roman numeral. So now on this side, I have a +1 and a +1, which gives me an overall +2 charge. +2 and -3 still don't cancel out. So I'm going to have to add one more copper. I'm going to squeeze it in right there, and it still has a +1 charge. +1, +1, +1, added together, give me a +3 charge. +3 and -3 do cancel out. So now I'm set. All I have to do is write this into a formula. My cation is going to be written first in my formula, so that's Cu, and I have 3 of those. 1, 2, 3. So my subscript right here is going to be a 3. That tells me I have 3 of that copper ion. Nitride is just N, and I only have 1 of those, so I don't have to write any kind of subscript for that. The formula for copper 1 nitride is Cu3N, and our I-bar helped us to figure that out. The last example that we're going to do here is aluminum sulfate, so again, an I-bar. Aluminum sulfate is my input. That's what's given to me. Aluminum from my periodic table is an Al. It has a +3 charge. It might be a little bit confusing because aluminum is highlighted or colored in like it's a transition metal. But if you look on the back of your periodic table towards the bottom, aluminum, zinc, and silver are transition metals that have only one oxidation state. So I know aluminum is always going to be a +3. I can also figure out that it has only one oxidation state because it doesn't have a Roman numeral in the middle. So that tells me I have to find this information from my periodic table. Sulfate ends in ATE, so it's going to be a polyatomic ion. And so if I look on the back of my periodic table, sulfate is SO4, and it has a -2 charge. And again, that's going to be the common polyatomic ions chart. Right now, I have a -2 charge on my anion and a +3 charge on my cation. +3 and -2 don't cancel out. This aluminum is trying to give away 3 electrons, but this sulfate can only accept 2 of them. So I need another sulfate that can accept some electrons. SO4 is sulfate, so we have to write that whole thing. Sulfate always has a -2 charge. If I have -2 plus -2, that gives me an overall -4 charge. Well, +3 and -4 still don't cancel out. And so now I'm going to add another aluminum. Aluminum is always a +3 charge. +3 and +3 gives me a +6 overall charge for my cations. +6 and -4 don't cancel out, but I can add one more sulfate here. And now -2, -2, and -2 gives me a -6 charge. +6 and -6 do cancel out. My formula, Al, I have 2 of those. And here's where it gets just a little bit tricky. SO4 is all together. So I have SO4, but I have 3 of them. I can't just put my 3 right here. If I put my 3 right next to the 4, it looks like I have 43 oxygens. That's not the case. We know we have 3 of this whole entire substance or this whole entire ion. So I have to put parentheses around this and put my 3 on the outside so that the 3 goes to the whole entire sulfate ion. That's as hard as it gets for ionic compounds. I want you to go ahead and try to write the formulas for mercury 2 phosphates, and for magnesium nitride. Bring those with you to class tomorrow. We'll go over the correct answers and any questions that you might have.